17th, wow. 12, 17, 18. So our standard, Common Core standard really has to do with triangle. Quinn, you don't want to go outside, do you?
Oh.
Well, then let's, okay. Triangle similarity. That's what this chapter is all about. So if things are similar, then they are proportional, okay? If any two figures are similar, we know they're going to have the same shape but different size, okay? We've talked about that. Same shape, different size. But the big thing we will learn is that they are proportional, okay? Proportional, which means they have the same scale, okay? They have a scale, same scale. Scale factor, like whether it's 1/2 as big, twice as big, 2/3 as big, but similar figures will have the same scale, right? Okay, good. So, let's take a look at number 1. And number 1 talks about the slope. Now the slope is a ratio. It really is a ratio, okay? And then one way to find the slope is by the slope formula. The second way is just by graphing it. It doesn't really matter to me. I'm going to use the slope formula because it's easier. The slope formula is just simply going to be y2 minus y1 over x2 minus x1. That's an algebra thing. We haven't seen that for a while, right?
We did last
Wait,
year.
this is the review? Question mark?
Yeah, this is the review. So,
I think we're reviewing this from like 8th grade.
so good, I'm glad. Okay, 0 minus 5 is over -4 minus 2, which makes a -5 over a -6, which is plain old 5, 6. Okay, that's my ratio. So you take a look at a line, and the up 5 over 6, up 5 over 6 is a consistent ratio on the whole thing. That's easy. Okay, and again, one of the things, if you have a difficult time with numbers, you can always graph it, right? Worst case, you can say, okay, I can graph this. Another way to look at it is 2, 5. And if I look at -4, 0, it looks like it's going to be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Sure enough, the slope is up 5 over 6. Just another way to do it, okay? Just another way to do it. Slope formula is probably easier, faster than graphing, okay? Thumbs up? Okay, good. You guys can all do this tomorrow, okay? Number 2, okay? So first of all, we looked at one like this. So there's 3 ways, and I'm going to put that in the column. 3 ways to show two triangles are similar. One is angle similarity, okay? That's the first way. If we have 2 angles of one triangle that are equal to 2 angles of another triangle, they're similar by angle. The other is side similarity, okay? We got 1, there's 2. Now the sides have to be proportional. They're not equal because these things are one side is bigger than the other. They're proportional, not equal, because similar figures aren't necessarily equal, they're just the same shape. And then the third way to show it is with side similarity. So again, we'd have to show that all 3 sides are proportional, okay? Those are the only 3 ways to show two triangles are similar, okay? So if I take a look at number 1 or 2A, well, for sure, that angle is equal to that angle. Those are called vertical angles. We know that those angles are equal when we think about something that opens and closes. But are the sides proportional? Well, let's check it out. Is 4 goes to 10 as 6 goes to 15? Is that a true ratio?
Yes.
Yeah, they reduce to 2/5 and 2/5. Go ahead, Zoe.
Why did we do it that way?
You can do it another way. Which way did you do it?
Why 415? Did that work?
Say it again. No, don't go 4 to 15. Because this side does not correspond to this side. This side corresponds to this side. Okay? And so that reduces to 2/5. 2/5, so we'd say yes by side similarity. That's what I want, okay? I want you to show me the work. I want you to show me the work, that they are proportional. Show me that the 2 angles are equal. And then give me the correct one, okay? Okay, number B, or letter B, sorry. Letter B doesn't really have any numbers, but it has some angles. Okay, first of all, we know this angle is equal to this angle because they're vertical angles. Okay, Those angles obviously are equal. And because of the parallel lines, this angle has to be equal to that angle because of the parallel lines, okay? Well, that's two angles. So if I have two angles of one congruent to two angles of the other, I could say yes, this one's by my angle similarity, okay? So far, so good. Now to do C, probably side, but what I'm going to do to make it a little bit easier for me is I'm going to redraw, and I'll even color it for you. I'm going to redraw this bottom triangle. I'm going to redraw it so that it looks more in proportion, okay? So if I redraw this one, redraw it down here, okay? And it's going to look something like this. And I'm going to put my, let's see, my 15. You okay with 15 being all the way across right there?
Yeah.
Okay, and I believe the 12 would go here and the 9 would go there if the whole thing turns around and flips. So let's see, are they proportional? Well, is 8 to 12, let's write this in, is 8 to 12 equal to 10 to 15, which is equal to 6 to 9, and let's see, that's going to be 2/3, 2/3, 2/3. So the ratio is 2/3. All three sides are proportional. All three sides are proportional, so we'll say yes by side similarity, okay? All right, how am I doing? Okay, slide it up to 3. Hopefully I'm not going too fast for anybody. If I am going too fast, let me know, okay? All right. Okay, so I see parallel, parallel, parallel. So if I see parallel, 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 they share this angle, then there are 3 triangles in here. There really are. And all 3 triangles have to be similar. So I've got a little itty bitty triangle here. Okay, and I have a medium triangle here. And I have my big triangle on the very outside. So there are 3 triangles that we want to look at, okay? So let's see if we can figure out what's going on. Let me label the whole thing. So this is 2.8 for FG, which is also 2.8, because that's DF. That's also 2.8, which is also 2.8 for BD. All right, so let's figure out what's going on. So if all 3 of those triangles are proportional, let's first of all call this X right here, okay? CD. So if we have to find CD, I'm going to look at 2 triangles. Okay? We cover up that one. So I'm looking at the middle triangle and the little one. So this side would go to this side as the entire length of the purple triangle would go to its little length, okay? So I'm going to set a proportion. I'm going to say, all right, I'll probably work on the side. I'll say X goes to 3. So this side goes to this side as, this is 5.6. This length is 5.6 as 5.6 goes to 2.8. Okay, how am I doing?
Terrible.
Okay, and I'll cross multiply and solve. 3 times that. So X is equal to 3 times 5.6 divided by 2.8, which is 6. Okay. So that's going to be X is 6. Okay, I know CD is 6. Okay. All right. 3, 6. What do you think AB is going to be?
9. I knew it.
It is 9.
Oh,
And we can prove it's 9.
I knew it.
And we know it's 9 because if they're proportional, they have to have the same ratio, don't they? So we don't need to really even do math. Yes, Caleb.
We don't need AB.
We don't need AB, so never mind. We got CD. You might tomorrow, though.
Well, we don't
Not
need
fair.
it.
Okay.
EF
That's
is
not
already there
fair.
though. It's 3.
It's not bad. Okay.
It's already-
All right, guys, thumbs up on that one. You do see the triangles, though. That's the trick, because you have to see a big triangle, a middle triangle, and a little triangle, right? Okay, 4. Okay, if they're parallel, we learned on Friday that we can say, let's just call this X, okay? X is easy to work with. We learned on Friday that we can say, this goes to this. Why not you guys just go outside, please? You're not doing anything. You're not going to go Sit in the hall. Go. Figure it out on your own. Go. Bye. You're not going to even try. You can just go outside. Enjoy. Okay. So, you ready? We learned on Friday if these are parallel within a triangle, then the sides are proportional. So I can say, all right, I can say that x goes to 12 as 6 goes to 10. And all I have to do is just cross multiply and solve. So I'm going to multiply it by 12. And I'll get x is equal to 72 divided by 10. 72 because 12 times 6 is 72. 72 divided by 10 is 7.2. Okay?
Go ahead. Use my email or PayPal.
Okay. All right. How am I doing? How's Torrin doing? You had a long weekend. It's okay. You guys, you had a long weekend.
Go ahead and share your weekend about it.
And let's keep going.
That's your
We
big thing.
worked from 7 to 1:30, and then that same
Yes,
day,
you guys all had long.
5 to 10.
Yes.
Wow.
Yeah. Did you guys work that night shift
We're not
also?
talking about you.
Did you, Quinn? Did you also work the night shift?
I didn't work.
Oh
I did
man,
it last weekend.
brutal. Anyway, back to math, right? So here's what we learned on Friday. We can say this side goes to this side as this side goes to this side. You ready? One more time. This side goes to this side as this side goes to this side. So I'm going to say my 2a goes to my 4a minus 2 as my 14.4 goes to my 24. That's a 2. That's a 2. That's a 2. So Zoe, what I do is whenever I have a z, I always put a cross through it because my z's look like 2's. I always do that because my z's do look like
That
2.
two doesn't look like a Z.
Yeah. Okay, so then I'm going to I went this side goes to this side as this side goes to this side. Cross multiply, right? That times that times that. So I get a 48a. Okay, 48a equals 14.4 times, ooh, got to squeeze this in, 4a minus 2. Squeeze it in, see if it fits. I'm going to distribute. I have 48a equals a. Let's see, 14.4. What's 14.4 times 4 equal? 57.6. 57.6. A minus 28.8. Squeeze it in. Sorry, you guys. See here, I've got a review for you right here, okay? If you want to come get it. There you go. Let's see. Let's go minus 57.6a minus 57.6a. Sorry, it's so sloppy, guys. I should have used a scratch paper or something. I should use scratch paper. 0.6, and I get an answer of negative 9.6a equals negative 28.8. Divide,
Doesn't
yeah,
hold up.
doesn't hold up?
0.6 minus 1 doesn't make 0.6.
Let me finish this and I'll see if I made a mistake, okay? I got 3. I got a equals 3. That makes sense.
But, okay, so 57.6.
48 minus 57.6 makes a negative 9.6.
How?
You got to subtract like the top number, like 50. Well, here, I'll just do it on my calculator. I'll just do my calculator. There it is right there. See my calculator?
Oh,
Yeah, honest.
Honest.
Well, let's say that you owed me $57.60. So you owe me, okay? So you give me a payment of $48.
What about negative?
You'd still owe me some money, wouldn't you? How much would you owe me?
I owe you like $9.40.
$9.60. That's what you'd owe me.
But then that would make 48.2,
No,
right?
no. You owe me $57.60. You pay me $48. Thank you for the payment. You still owe me that 60 cents. Think about that. You still owe me the 60 cents. Don't you still owe me the 60 cents? Go ahead and do it on your own, okay? Okay, now, if A equals 3, then this side is 6. You guys agree? You guys agree this side's 6? This side's, let's see, 3 times 12. And this side's 10. That side's 10. Yeah.
So what 14.4 over 24.
Oh.
But two, before I even started all the math, I got 7.2 over 12, and then did all of that, and still got the right answer. But it was a lot easier because you weren't doing it with one.
Yes, absolutely. Yes, like, can we just leave it there? I don't want to go back to it. Yes, nice job. Because if it's a ratio, it's a fraction, just reduce it. Well done.
Good
Okay,
job.
I'm not going to show it because I don't want to confuse anybody, but you're totally correct. Nice job, Ashley. Okay, moving it over. Okay, here we go. So, parallel, right? Which means if you were to draw a big long triangle, then it would be proportional. So, you know that this side goes to this side as this side goes to this side. So we're just going to set it up. We're going to go, okay, 3 goes to 5 as x goes to 7, right?
Yes.
Oh, my bad. There you go. Right? So it's all a matter of just setting up fractions and cross multiplying. That's mostly what this test is about, right? Cross multiply. I'll bring the 7 up here. I'll go 21 over 5 equals x. Let's see, what's that? A 4 1/5? That's a 4 1/5, I believe, right? 5 goes into 24 times the 1 left over, 4 1/5. Or 4.2 or decimal, whatever you guys want to do, okay? Even 21/5 I'd take, right? Lan, you got a question?
No. Not
Okay.
anymore.
Okay. All right. Find TS. So TS, just call it X for now. I like X. It makes it easier to work with, okay? So same thing. They're proportional, right? So I can say this side goes to this side as this side goes to this side. So how about if I just put a 18? Yeah, okay. 5 over 8. You want to do it that way? 5 over 18 equals 4 over X. Okay, that sounds good. Less work if X is on the top. Well, yeah. Because you got to go the same way, right? If you're going to go that to that, that to that, right? Are you with me? You got to be consistent.
But that's okay.
Okay, no, you have to be consistent. You got to go this to this,
And that's that.
right?
But that's 18 too, right?
No, 18's right here. We don't know what this is. That's what we got to find out.
Looks like 18.
5x equals, I don't know, what's 18 times 4? I don't know.
18 times 4 is
72. Divide by 5. I got 14.4.
I told you it was 18.
No, it's 14.4. Okay, all right. So, do these two triangles look similar?
Yes.
They are. But you got to be careful because K goes to N. Does that make sense?
Yes.
And J
Goes to N.
goes to M. Everybody agree with that? Okay. So then it's pretty easy. So if this is 78, then this is 78, right? I'm going to get M from 180 degrees, right? 180 minus 78 plus 40, right? 180 degrees in a triangle. That's easy. All right, let's do that real quick. 180 minus parentheses 78 plus 40, and I'm going to get an answer of 62. Okay. So that means J is also 62, right? This angle here at L, but you can't call it L, you got to call it KLJ, because L is very ambiguous. Which one is L? I don't know, but KLJ is 40. Okay, and let's see what we've got. Okay, angle J, that's easy. Angle J would have to be 62. Capiche? 62. Okay, angle N,
78.
78. KL, well, I don't know what KL is, but I know they're proportional, okay? So let me call KL X for right now. You all right with that? So X goes to 10 as 20 goes to 8. You guys see it? X goes to 10 as 20 goes to 8. You guys see that?
No.
So X, this side, these two go together, just like these two would go together.
But we're doing
Big triangle, little
L.
triangle.
Yeah, we're doing KL.
So it's X goes to 24.
KL. Oh, KL. Oh, I was doing that. I was doing LM. Okay, let's do it Y then. Okay, KL. Y goes to 24 as 8 goes to 20. KL, right? Okay, KL. Got it. This goes to this as this goes to this. Let me show it again. This side goes to this side as this side goes to this side. Okay. Okay. So I'm going to say Y goes to 24. As 8 goes to 20. How am I doing? Okay, multiply by 24 to make it easy. What's 8 times 24? 192. It's okay. Divided by 20. Uh-huh. I'm just using a calculator. 9.6. Sorry, Caleb. I'm just using a calculator. I'm glad you're trying to do things in your head. Okay, now let's do LM. My bad. I was trying to do LM too easy. Okay? LM. This side goes to this side as this side goes to this side, or X goes to 10 as 20 goes to 8, right? So X goes to 10 as 20 goes to 8, right? Multiply up the 10, that's 200, Caleb.
Yeah, I got that one.
That one I can do in my head, huh? Divided by 8, I think that's 25, right? 8 quarters? It's got to be 25. Okay, can you do something like that tomorrow?
No.
Okay, and let's do one more. Last one, this is kind of like the one that Chrisia did, which is kind of nice because we're going to graph it to figure it out. So I'm going to do 2 different colors because I'm going to have 2 different triangles. So first of all, J is at -1, 0. There's J. K is at -3, 1, 2, 3, 1, 2, 3, 4. Okay, let me label these. That's my J. That's my K. My L is at negative, or is it positive 3? 1, 2, 3, and -2, 1, 2. There's my L. M is at -4. Let's see, -4. 1, 2, 3, 4, and -6. 1, 2, 3, 4, 5, 6. That's M. And N is at 5. 1, 2, 3, 4, 5. 1, 2, 3, okay? So there are 2 triangles in here, okay? Let me see if I can show them to you, okay? First we got the triangle, the little triangle on the inside. I'll do that in yellow, right? Okay, see that one?
Oh, I see it.
And I'm going to have a bigger triangle that I'll put in orange, okay? I'll get my orange one. Uh-huh.
K is.
Am I off by 1?
-3, -4.
Oh. Thanks. I'm glad somebody's watching what's going on. Thank you. That would have messed me up bad. Was that Owen or Aiden?
Aiden.
Thanks, Aiden.
That one.
The good-looking one, huh?
Yeah.
There you go. All right, and there we go.
Wait, but if you dilate a triangle, don't all the points move?
Yes, they would. I just put one of my points in the wrong spot. That's me not knowing
Oh,
how to graph.
but then would there be 3 new ones?
No, I just put that in the wrong spot. Let's see if it is.
Scale factor, not
Okay, now.
Caleb's having a rough day.
Now, first of all, there are, let me flip page real quick, okay? There are 3 ways, there are 3 ways to prove 2 triangles are similar, right? The easiest would be angle. You guys agree? Yes. The easiest angle. So one of the first things I can do is I'm going to try angle. I'm thinking angle, sim. But first of all, before I even do anything, don't they both share J?
I have a
So
question.
that's the easiest, right there. Right off the bat, I'm going to say that angle J is congruent to angle J. Okay, I got one of the 2 angles, okay? Yeah, Caleb?
Are we finding the scale factor or not?
We're going to have to figure out the scale factor, yeah. Oh, is that all I have to do, scale factor?
So we're determining it, not finding it.
Yeah, well, I'll do that too. Okay, and I do know, let's figure out what the slopes are. So, the scale factor, doggone, I should have done the scale factor. It's okay, I'll do the scale factor. Well, like, how much bigger is it? So, if I, now that I have them graphed correctly, thank you very much. Okay, I know they're similar. If I could find the length of MN, and if I could find the length of K, let's see, N, right? Okay, here, this is the hard one, but we can do it. All right, let's see if I can describe. So if I know the length of K, N, and if I know the length of M, is this L?
Yeah.
I am ML.
What?
I'm messing this up.
Yeah,
ML KN. Got it. Okay? My bad for messing up, but I'll fix it. Okay? So what's the length of ML? How can you find out what the length of ML is?
So you do the little triangle.
There you go. See if I can find it by Pythagorean's theorem, right? So let's figure it out, okay? So I've got a little mini triangle right here. I got 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. So I'm going to go at 9 squared plus a 3 squared. 81 plus 9. I get the square root of 100, which is what? Square root of 90. Boy, I'm really having a bad Monday. Square root of 90. Okay? And then let's figure out what the length of Kn is. Let's see, that's going to be a 1, 2, 3, 4, 5, 6, 1, 2. That's going to be a 6 squared plus, did I say 2 squared? Which is 36 plus 4, which is square root of 40. Okay? I should probably do this again. Square root of 90 over square root of 40, okay? Which, let's see, is the same thing as the square root of 9 times the square root of 10 over the square root of 4 over the square root of 10. I'm going to cancel the 10s. You okay with that? Square root of 10, square root of 10. What's my scale factor? 3 over 2. Ah, there.
That's a lot of work.
Yeah, so one hard question on the test is okay. Okay, now,